Hello and welcome to the Force in Motion third grade lesson 3 video. So in this lesson, bring back the flow chart, we have looked at the initial engagement activity, kind of negotiated a little bit of a meaning, established a big idea, and now you're selecting a question. Just a note, it doesn't matter what these 3 investigations that you'll complete. There is no rhyme or reason for the order they're in on this document, so you could do it in any order you want. It does not have to be this one, then this one, then this one. If students were really interested in magnets, you could start with magnets. If they're really interested with cars, they could do that first. Doesn't matter. Just for the sake of the way I have it laid out, we'll just do the rocket one first. So this would be for the activity or the investigation for 3PS2-1 about balance and unbalanced forces. Now, another thing I want to mention is the question that your students come up with might be slightly different than the question that I have here, and that's fine, and run with it as long as it has something to do with balance and unbalanced forces. And there's a lot of different routes you could go with that in this lesson. You could do the shape of the nose cone, you could do the shape of the wings, you could do the weight of the rocket. There's a lot of different things that you could do because we could always tie it back to balance and unbalanced forces in a way. So the one I have set up is the size of the wings of the rocket. The size of the wings, the shape of the nose cone are definitely going to affect how high it goes. So you'll see some contrast with those two. So those might be 2 easy ones to potentially target as far as your test. Weight might be a little tricky. You're going to have to really manipulate the weight of the rocket. It's going to be a bit challenging. But so just kind of give you that heads up. But feel free to go with any question that your kids come up with, because that's a big part of this approach, is really to make it truly student-centered. You do have to honor their questions. However, the way we get around from kind of quote-unquote crazy questions that aren't related to the content that you have to teach is we say it has to fit under the big idea. So that usually kind of helps alleviate some of those problems. Now, as far as the lesson, you'll be down here on page 5 of your thinking log, because this investigation is going to be an experimental design type of investigation. So you will be controlling variables with this one. So again, if you were going to start with the, let's just say size of wings for the sake of argument, you would begin by having a short discussion about variables and controls. So just to make it simple, I mean, you can even simplify this a little bit more if you want. You can, instead of call it an independent variable, you could just call it a variable. So if you wanted to, get rid of this and just call it a variable, that's totally fine. But you would start out with just thinking or talking to your students about, okay, we're going to do a test about, does the size of the wings affect how high that the rocket flies? So you might even want to write that question out here when you just kind of introduce it to your students. You might even want to fill in the variable for them so they know the size of the wings of things you're testing. But then what I would do is I would have them all individually fill this out. What are the things that are going to have to be controlled? So you're going to have to do it in the same area at the same time of day, to affect for like wind and things like that. If the wings are the things we're manipulating, then the nose cone has to be exactly the same. The body of the rocket has to be the same. They all have to use the same type of paper. It has to weigh the same. All those things have to be the same. But so have the students fill this all out themselves individually first. And then we're going to get into small groups and eventually whole group later. This is another big one. How will data be collected? To make it simple, there are some tracker things I can show you if you're interested in getting very accurate, but just a simple way to do it that we have set up in the thinking logs is just do a stopwatch. And as soon as you launch it, run the stopwatch and wait till it hits the ground. And for the most part, it'll give you a fairly accurate of which one went higher. We're not being super specific isn't the most important thing with this investigation. We're just trying to see with the different wings, which one went higher. So, but I wouldn't tell them that and just see if they can figure out a way to do it, because they're going to say stuff like, oh, take a ruler, but then that'll be a great negotiation opportunity in the next lesson, or actually in this lesson, to say like, well, this thing's going to go like 100 feet in the air. Can we really measure it with a ruler? Something like that. Materials needed and step-by-step what they're going to do. So again, have every student do this first individually, then get them in small groups and kind of talk about that as far as like what they did. So I'd maybe have them share around, okay, what was all your controls, and then go around the class, around the small group, and say, did we all have that, or did somebody think of something different? Then bring it whole group and kind of plan it out with you sort of leading it, but taking different ideas from the students. And then, and again, so this might take more than one day, so it might take a full day of just planning it out. Then you have to build the rockets. So I do have these PDFs right here if you're interested. This is a simple one that you can make the nose cone and the body all the same by doing this. Another one here for the wings. So we have some large wings and some small wings on here, and you can just cut these out. So there's the large one, have like 4 of them on one rocket, and then you could have 4 small ones on the other, and that might be good enough to manipulate the height that it goes. So again, you don't have to do this question, but here these materials are ready for you, but it would be very easily to manipulate the nose cone or something like that. So by the end of this lesson, you'll have the rockets built and ready to go, and you'll have the investigation all planned out. We think that this is really vital to have kids involved with the planning of the investigation, because nature of science is really tricky with kids, and there's been some research that shows when kids are actually given some autonomy and some control where they can actually plan it themselves, it helps them get a better understanding of the nature of science. So even though this lesson might also take a couple days, it's worth it to spend that extra time to get them thinking about variables and controls.